Hello everyone, this is Gleb Bakhmutov and this is a companion video to my click multiple checkboxes about Flake blog post. I'm going to put the link to the blog post in the description of this video. But we have a pretty simple test. It visits the to-do MVC, confirms that there is, well, in our case it's a random number of items, clicks all the checkboxes, reloads the page, confirms that all the to-dos were completed. And right now this task created two to-do items, checked all the boxes, reloaded the page, and the count of remaining items was 0. We can run this test multiple times. It creates different number of to-dos between 1 and 10, and everything seems to be fine. But once in a while it fails. So let me just rerun this test multiple times just to make sure that we see a failure. Okay, I want the whole test to fail. Okay, sometimes it might take a little bit. Okay, right now. Notice that the test had actually one item. It clicked on the checkbox, it reloaded the page, and it still has one item to do. Let's maybe see a failed test. Again, one item failed. Okay, failed again. There is a flake in our test, mostly successful, but once in a while it fails. So the first step in finding a flake test is to kind of look at the commands that we do. And one of the red flags is executing multiple commands without any assertions in between. So right here, this is a query. So we're looking at the checkboxes and then we click all of them. So clicking is the command. We only do it once because it changes the state of application. It changes the data, right? So click is a command and it's followed by another command that reloads the whole page. Now, in between, we don't check if the click, whatever application is doing, has finished its work before reloading the page. So if application is slow, then the click might not finish processing before we reload the page and kind of lose the action. So one of the first things I like doing is alternating and after commands adding an assertion to make sure the command has finished whatever it's doing before the next command executes. So a good way to check if clicks have finished is to check the remaining count before we reload the page and confirm the remaining count is 0 again. So right now it seems to have helped. Notice we had 3 to-dos, all of them were completed, we reloaded the page, and again it shows completed. And it works pretty well, but it doesn't work in 100% of the times. Let me just run this multiple times until we see a failure. It's rare, but it does happen. Okay, right here. So notice we created 3 to-dos. We clicked on multiple elements. So first checkbox, second, third. We confirm the UI is showing 0 items left. We reloaded the page and there is 1 item left. So what has happened? Well, here's where we have to look at what our application is doing and how it relates to the test itself. So luckily, the Cypress command log is right here. And one of the beauties of Cypress command log is right out of the box, it shows you your commands and assertions from the test and the network calls the app is making. The app is making at the start a get to do, so it's loading the data after we visit. So sometimes that call is shown like after the next command because they happen at the same time. Now we're clicking and look at the first click. So after we click on the checkbox, the application is sending a network call patch to-dos ID of a to-do item. We're using a REST API. We have a state in the browser on the front end. So that updates in response to the actions, and it also sends updates to the backend where it's stored so that when we load the page, we get the to-dos again and we load the state. Now notice right here what we can see something kind of weird. We clicked on 3 checkboxes, but I only see 2 patch calls. So patch, patch. So that gives you a clue that there is a discrepancy between the UI actions and the number of updates sent to the backend. And anytime you have a failed test, if you can look at the command log or you can use Cypress Cloud or you record it on some other reporting, if you can see the commands and compare them to the successful run, that's the best. If you can enable test retries and on the first retry it fails and succeeds on the second, that's the best comparison because these runs are close in time. So let's rerun this one more time. Now notice right here it's 1, so let's maybe, okay, so 2 is a great example. In a successful test, when we click on 2 checkboxes, we see 2 patch to-dos calls. So what happens? Well, in this failing test, again, luckily it's just 2 items, it seems like when we click on the first item, the application is sending the patch network call. When we click on the second, the UI seems to have updated already. We reload the page and we don't give the application a chance to send the update, like the patch call, to the backend. So the last call gets lost. Okay? So we have the front end state in our browser, which to-dos are completed, and it gets out of sync with the backend state. We reload before application has a chance to send the network update. Okay, we see the failure. Let's see how to fix it. And there are a couple of ways we can do it. So if we're clicking on end checkboxes, then we expect to see end patch to-dos calls. So that's one way of waiting for application to finish everything it's doing before we reload the page. So let's do this. And I'm gonna leave this UI assertion because I think it's actually a good assertion to confirm the front end has finished before we do anything else. So right before we click, we can set up a sci-intercept. And if you don't know how to use sci-intercept, I have a whole online course that I'm gonna link. It's a very powerful command, hundreds of lessons of how you can use it in your web application. So once we click the items, the UI updates, we can get all update calls using sci-get query and then .all after the alias, and we can say should have length, and it should be the same number as the number of to-dos we clicked. So this syntax confirms that there are all the calls that happen for each item. So let's see how it works right now. And just to make it clear, I'm going to go into the application and I'm going to modify the implementation, right? So when we notice toggle the to-do, we actually create a 70 millisecond delay before we send that patch network call. And at the same time, we update the UI. So that's how the UI in a browser can get out of sync with the backend because we add this random delay. When it's longer, we kind of lose the network call because if you reload the page, all the scheduled network calls are canceled. So just to make this very, very clear, I'm gonna increase this, let's say always be 1 second. I'm gonna remove a random part so that our test always has slow communication with the backend. So if I run the test, notice what happens. Notice it clicks multiple elements and then all the calls are executed after 1 second, but we still wait for that array of update all network calls to have length of 2. So let's rerun this a bunch of times. Notice even if there is a longer delay, right, it still waits for all the calls, then reloads and then confirms that 0 items left is displayed. So this is flake free. Now, one thing that I don't like about this test is that we're doing this click with multiple true, and it clicks really fast, right? Because it's a computer, right? It clicks immediately after the checkbox is clicked. And there are 2 problems with this. The human user cannot click that fast, so it's unrealistic. But even aside from that, we're using the sci-click command on a checkbox, and I actually prefer using sci-check command on a checkbox because it has implicit assertion that the checkbox is not checked as initial state. I believe so. I might be wrong, but I don't want to look it up right now. All right, so let's replace sci-click with sci-check. And the problem is there is no multiple option for sci-check command. So we have to do something else. We have to click unknown number of to-dos one by one. So what we can do right here, instead of clicking, we're gonna use sci-each command. And it's gonna give us a checkbox as jQuery object. And if you want to take that DOM element or the jQuery object and use Cypress commands, you need to wrap that, and that will start a new Cypress chain. It will insert it in the correct way in the chain of commands already scheduled. So we don't want to log that because that creates a lot of noise in the command log. So, and we can use check. Now we don't want to force it. Let's see how this works, and it works the same way, right? Just does it one at a time. Check, check, check. Perfect. Now we can modify this assertion. So instead of checking all the network calls at the end, we can wait for each call one by one. So scget simply queries the list of calls made. Scwait waits for the next call to be observed. So it kind of uses them up one by one. And when we check one to do, we want to wait for one network call. And right here, once we check, we maybe want to look at its status code. So we can say its response, and let's say its status code 200. Now, in this case, it's very interesting to see how it works if we have more than one to do, let's say from 3 to 10. Okay. Now notice right here we have 8 to-dos, and it checks them one by one, and we wait for the network call to happen, which has 1 second delay, so the whole thing takes 8 plus some change seconds. So pretty nice. We confirm that after we check the box, the call is made, and that call is successful. Now, another thing we can do right here, we're checking the front end, and we confirm that the network call has finished. We can avoid all of that by going to the backend and asking, do you still have incomplete to-dos? We don't have to wait for the application calls. We can check the backend. And this works if, for example, we don't know how the calls are made, or they're done using WebSockets or some other way that is not easily observed with scIntercept. So we know that at the end, so there is no more Flake. At the beginning, the application is making scget to-dos call, so we can actually do that call ourselves. So what happens? We're gonna check all the boxes one by one, and I'm gonna remove the intercepts for now. And what we're gonna do is, after all the calls are made, we can make the request. So get all the to-dos, and this will give us the list, right? And it will be objects, right? So we can look at what the application is. So I'm gonna just clear it. If I look at the get call right here, let's run this again. So right here, notice there is a list of to-dos, and it has completed field. So from this list, we can say then to-dos, map completed, right? Now, there is a problem that request is the command, and we can just say all the booleans should be true, right? It will not retry the request. We have to do it ourselves. And for that, I have a little utility called recurse. So import recurse, already installed Cypress recurse as a plugin. And what it allows us to do, it can say, okay, this is a function that will produce some data. Okay, so the first function yields data. And once you yield the data, you pass it to a predicate. So right here, let me just remove this. Okay, so we need a predicate. So we have to-dos. And we can say, well, we return true if everything is completed. Okay? So right here, what happens? Cypress recurse will retry the first function until the predicate returns true. Okay, so it will keep doing requests, and you can see the request right here done multiple times. Okay, now we don't have to try that often. We can provide some options. We can say, for example, timeout, let's say 10 seconds, and delay maybe, let's say 500 milliseconds. And instead of just logging everything, just like as a yielded object, we can say all to-dos updated, okay, on the backend. So notice right here, it just calls request, and then at some point all to-dos were returned and all were completed, and everything has been updated on the backend. So our front end calls multiple times the patch call. We don't care about that. We just check the backend. Once the backend has been updated, has no more incomplete to-dos, then we reload the page. So that's Cypress recurse. Finally, one last thing about working with each item one by one. So we create a list of to-dos, and each to-do has an ID. In this case, these are random numbers. And if we update all these to-dos, we call all this patch to-dos ID call. We want to confirm that that list of to-dos we update is exactly the same list of to-dos we created. And this confirms that, for example, we update all to-dos in order, right? Which is maybe a property we want to assert. So what we want to do, we want to check each item. We want to spy on the network call, collect the ID, and then confirm the list of IDs against the original list of to-dos IDs we created. So back to our code. I don't want to use Cypress recurse anymore. And I'm gonna intercept the patch calls again. Intercept patch to-dos as update to-do. And I'm gonna remove all of this. So right here, I'm gonna wait for update to-do. I'm gonna grab its, I guess maybe response by, let's see, what does the patch call do? Can I grab the ID from somewhere? So if I look at, let's say, this call patch, right? Let me just look at the network tab again. Okay, so a patch call. Oh, the response has the ID. Okay, perfect. So I can say response body ID. Okay, and here's a problem, right? We can, for example, collect those IDs here. We can maybe push each thing, IDs, push ID, and then we can say fine, maybe, and we can say syrap IDs should have length or should like maybe deep equal to the list of IDs from before that we created. Now it's pretty unwieldy, right? We have to create a local array so we can push the IDs we extract from inside each callback. And then we have to wrap IDs so we can work with this list of IDs after all the previous commands have finished run. And it would be much nicer if we could just shorten this and maybe somehow maybe yield IDs here, right? The problem is that each really yields the original list of elements, and in fact they don't recommend you to use that list because the application might have re-rendered. It's very unpredictable. So in addition to Cypress recurse, I'm gonna import, or as alternative implementation, I'm gonna import my Cypress map plugin. And it has a lot of query commands that I think useful to day-to-day test writing. But one of the commands is a replacement for each, or each, and it's called map chain. And it's called map chain because it actually does two things. First, it maps. So whatever subject you give it to, like a jQuery, which is just a list of elements, it will map to whatever you want. So it will map to the result of the last command inside the callback. So the way you would yield the IDs is to just yield the ID from each one. Okay, so we have a jQuery object, which is an array of elements, and we're going to map that array of elements to an array of IDs where each ID is for each element. Okay, so whatever we found in the DOM, we make a network call. Oh, whatever we click, it makes a network call. We wait for that network call. We grab the ID returned by the backend. We yield that, and it automatically goes into the array yielded from map chain. And the second part is the chain, meaning that whatever is in a callback, whatever Cypress command you execute right here, will be executed one by one, one after another. So it will be added to a chain of commands that already has all the commands in the test, and that thing will just insert them in the correct order, in correct place. So we grab this long list of elements, and for each one, we check the box, and we yield the ID, and we get the list of IDs after it's all done. So let's see how it works. So we have 10 10 to-dos. We have a list of IDs we expect to patch. And once everything is done, notice right here, we expect that array to deeply equal another array. Now, if you want to see the values from that array, you can, there is an option that's global. Just for easier demo, I'm just going to say, just create a few IDs so you don't collapse the, right? So right here, it's 1. Let's say at least 2. Perfect. So our application updated all 3 to-dos, and the correct IDs were patched and in the correct order. What are our warnings? Oh, I'm doing the type check right here, and this jQuery parameter just has parameter any, and this is JavaScript, so I can still do like type jQuery element, and now it knows the right type right here. So that was a pretty long video. Read the blog post. It shows each way of solving Flake step by step with all the links to the plugins that I used. But even if you don't want to use any plugins, the built-in Cypress commands, especially network monitoring, can give you a very solid test where the test never runs faster than the application is doing things, and where you can check the backend state before you continue.